Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from Probability and Statistics 1. And the questions belong to paper 9709/52 for the session May June 24. Question number 3 is the weights of oranges can be modeled by a normal distribution with mean 131 grams and standard deviation 54 grams. Oranges are classified as small, medium, or large. A large orange weighs at least 184 grams, and 20% of the oranges are classified as small. And question number A says find the percentage of oranges that are classified as large. So from the question we have come to know that it is nothing but a normal distribution based question. And for normal distribution the parameters are what? We know that parameters of normal distribution is nothing but mean as well as variance. Mean is 131 and variance is square of standard deviation, which is 51. So it is 54 squared. Well, then they have told us to find the weight of the oranges which are classified as large. So what is written about large? A large orange weighs at least 184 grams. So that means it may be greater or equal to 184 grams. Then we will standardize the score. Probability of Z greater than 184, and then we will find the z-score of these. Z-score is going to be Z greater than, you know how to calculate this, 184 minus mean is 134 over standard deviation, which is 54. Now a question may arise in your mind that when we started our writing, the question told that x is greater than or equal to 184 grams, but when we standardized this score we have written only greater than. Actually in normal distribution they have already told that it is a normal distribution question. Then in normal distribution question it is already applicable for continuous random variable, so there is no necessity of doing continuity correction. That is, suppose here there is 184 gram and they have told that at least 184 gram, that means it may be 184 and more than that. So this is this portion, as this is continuously randomized, so it will be just more than 184, and equal to 184. It's all the same in case of probability. Right side is the probability which have which has the oranges weighs more than or equal to 184. That means simply we don't need to do continuity correction in this case because already it is distributed normally. Well, then if we find the z-score is going to be 184 minus 134, not 134, it is 131, sorry. Here we will have to write 131, not 134. So let me write here 131. Well, so 184 minus 131 over 54, our z-score is 0.981. Well, then we will write here the probability when z-score is 0.981. Then let me draw a graph of normal graph. Suppose this is the normal graph. Here this is the mean line and standard deviation z-score is 0, and they have told us to find, suppose here the z-score is 0.9 because it is positive, and they have asked us to find the probability of this portion. Look at this, it is given z greater than 0.9, that means this portion is our probability. So what we can do in this case, for any normal distribution curve, always the probability lies on the left side. If I show you using this, look at this. In the normal distribution graph, always the probability lies on the left side. That means the probability lies left side of the z-score. But here the question told us to find the right side of z-score. So what, how can we find this? What we will do, we know that normal distribution graph is symmetrical graph. So easily what we can do is, from whole of the probability, if we subtract this left side, if we subtract this left side, we'll definitely get this probability which is lying on the right side of the z-score. So from whole probability is nothing but 1. From 1 we will just subtract the probability, the region which lies left to the z-score less than 0.981. So once again I am repeating that we are just subtracting the left region, that means probability which is lying on the left side of the z-score, for getting the tiny part lying on the right side of the z-score, because in probability distribution table all the probabilities lie on the left side of the z-score. Well, so for this our probability is going to be, what is the corresponding probability for this z-score is 0.8364, then 1, for 1 it is going to be 4, so 0.8368 is the probability. Then if we just find the result after subtracting this from 1, it is going to be 0.1632, 0.1632. Then they have told us to find the percentage. Look at the question, they have told to write the percentage of the probability. Okay, find the percentage of oranges that are classified as large. So if we convert this quantity into percentage, it is going to be nothing but 16.3%. Well, if we round it up to three significant figures. Now I am going to show you how we found this probability for this corresponding z-score. So we will not forget our z-score. Our z-score is actually, this is our z-score. This is our z-score is 0.981. For this, you may ask that why should we undergo such botheration, that is easily it can be obtained using calculator, but some students find it comfortable using the hard copy of normal distribution graph. That's why I'm going to show how to find the corresponding probability for a particular z-score. So let's move on to the image. Well, image of normal distribution is the graph of normal distribution. Okay, not over here, on the other page. Suppose on the first page we can write, or let me find a blank page. Suppose this is a blank page. Over here we will attach the normal distribution graph. Yes, this one. So what was our normal, I mean z-score? We should not forget our z-score was here. It was our z-score. What was our z-score? Our z-score was nothing but 9.981. Well, 0.981. So look at this. Our z-score is 0.981. Point 9. Where is point 9 located? This is point 0.9. Okay, point 0.9. Then 8. Where is 8? Here. This is 8. And again there is 1. 0.98, then 1. So what is our probability? First of all, this one is the probability. How much is this? This is 0.86, no, 0.8365, 8365. We to which we will add up this one, this three. If we add up this three, so how to write? 0.86, sorry, 836. It was 5, then we will add up 0 0 0 and 3. So if we add up this, it is going to be 0.883, 0.8368. So this is our probability we have used. Let's see whether we have used 0.8368 for z-score 0.981 or not. So 0.8368, 0.8368. Yes, we have used this. This is the probability for corresponding z-score of 0.981, which is 0.8368. So that's all about the solution to question number 1a. Let's move on to question number b. What does question number b say? It's on the next page. Question number b says, find the greater possible greatest find the greatest possible weight of a small orange. Still we are under the same distribution, same normal distribution, so we can write here that x belongs to normal distribution. X belongs to normal distribution. What were the parameters? We have not forgotten. The mean was 131, first parameter, and secondly our second parameter was variance. Variance was the square of the standard deviation. Standard deviation was 54, so 54 square. This is our parameters. Then they have told us to find the greatest possible weight of a small orange. So it is going to be probability of uh, x is greatest possible. That means it may be less than or equal to s. We can write s for small weight of small orange. Then if we standardize the score, it is going to be z less than s minus mean. Our mean is 131 and standard deviation is 54. Okay, so now again you may ask that why did we skip this equal symbol? Actually less than or equal to s means it is normal distribution. In case of normal distribution, the variables are already normalized. It is normal distribution is applicable for continuous random variable, so there is no necessity of doing continuity correction. That means less than s or equal to s, actually it will be the total quantity will be same, probability will be same as I have shown in the previous one. Now let us calculate this. It is going to be z less than, yes, for large, look at it, for small orange something is given, probability is also given. What is the probability? Let us see the probability of small orange at page number 4. So what is written about small orange? Look, 20% of the, this is, let me change the ink, this is 20%. 20% of oranges are classified as small, so probability is 0.20. So our probability is for for a small orange, probability is what? 0.20, 0.20, 0.20 equal to 0.20. Then look at this. For 0.20, if I show a normal graph again, it must be negative. Look at this. So this is our normal graph. Okay, then this is 0, that means the midline or median. Then they have told us to find the probability of this portion. Which portion? This portion. If we look at the z score, Look, z score is, they tells us to find x is less than this score, isn't it? Now probability of this region, probability of this region is how much? It is given zero point 0.2. If it is zero point 0.2, what about the right side? Let us draw. So it must be, if left side is zero point 0.2, definitely we know the total probability is what? 1. So if left side is zero point 0.8, definitely the right side is 0.8. And here our z score is s minus 130. Definitely it is going to be negative. Look at this, on the left side all negative, z score stands, so it is negative s, s minus, s minus 131 over 54. This is our z score. So one thing is very sure, that our z score is actually negative, because it is lying left side to the mean line, or mean standard deviation means 0. So from all values lying on the left side is negative, and all values lying on the right side is positive. So one thing is very sure, that our z score is negative. Now we will have to find out the corresponding z score when the probability is 8. Okay, probability is 0.8. As we have used the normal distribution function in the previous case, here also we are going to do so. For when z score is, I mean when probability is zero point 0.2, then our z score is going to be mm, 0.2, means for point, actually all the probability, if the two probabilities are there, zero point 0.2 and zero point 0.8, always we will look for the greater probability, because the probabilities given in the normal distribution function are more than 0.5. So always we will choose for the greater probability. So here greater probability is zero point 0.8, and z score will remain same. Already we have decided that z score is lying on the left side, it's negative, but for the left side or right side it will not affect our probability. We require the z score, so z score will stand at the same position, but as the curve is symmetrical, so for right side or left side z score will remain same. And as there is no probability given less than zero point 0.5, that's why we will find the greater probability. I think you got my point, that no probability given less than zero point 0.5, so always we will find the greater corresponding probability. Let's see, when the probability is zero point 0.8, how much is z score? The z score is going to be minus 0.842, that is minus 0.842 minus 0.842 equal to this probability is 0.20. So what have we done here? We have just found the probability z score for the corresponding probability of zero point 0.8, because zero point 0.2 you will not find zero point 0.2 in the normal distribution graph. And this is a clue, whenever the probability is given less than zero point 0.5, then we will opt for and we will use the greater probability, and z score will remain changed. We can find the direction of z score. If z score lies on the left side, it will be negative, as like as this one. If z score lies on the right side, then it will be positive. Otherwise, for probability, always we will use the greater quantity. So greater probability is 0 0.8. For probability of 0.8, the corresponding z score is 0.842. Hence we can write here, as both of them are z score, so definitely this quantity will be equal to this quantity. They must be equal. So s minus 131 over point, sorry, over 54 over over 54, we have already decided it is negative, equal to negative 0.842. Well, let us calculate this. If we simplify, then it is going to be S is equal to 54 into, it must be negative, minus 54 into minus 54 into 0.842 plus 131. Hence our S means least weight of a small orange. The greatest possible weight of small orange is, it is going to be 54 into 0.842 plus 131 is equal to 85.5 gram. 85.5 gram. So this is the least greatest value of, that means all the oranges weighing equal to 85.5 or less than 85.5 will have this probability of 0.20. I think you have understood my point. So here just only the point is, whenever the probability is given less than zero point 0.5, then we will find the corresponding z-score of the greater probability, just the vice versa. Here the greater probability is zero point 0.8 and the corresponding score for probability of zero point 0.8 and zero point 0.2 will be equal. Just there will be the change in symbol. We should be very careful about the symbol. If z-score lies on the right side, it will be positive. If z-score lies on the left side, it must be negative. That's why we have used here negative symbol. So I think you have understood how to find and solve this question. So let's move on to the immediate next question. Question number 4 says, the back-to-back stem and leaf diagram shows the annual salaries of 19 employees at each of two companies, Petrol and Raven. Petrol is lying on the left side and Raven is on the right side of the stem, back-to-back stem and leaf diagram. A key has also been given to 31 5 means $31,200. Look at this, we should not ignore this. Here there is a very crucial information, which is this. Look at this, two zeros should be added with each quantity. Well, then question number 8 says, find the median and the interquartile range of the salaries of the petrol employees. It's all about petrol. Okay, let's start our solution. Let us mark the lower quartile, median and upper quartile. So it's all about petrol. Look at this, total there are 19 employees. If there are total 19 employees, so median, this is median. Look at this, 10th quantity, because 19 plus 1 is 20. 20 divided by 2 means 10th. So 10th quantity will be, or a 10th time. Here what is this, annual salaries, 10th salary will be the median salary. So let's find 1 2 3 4 5 6 7 8 9 10. So this is the median salary for petrol. Okay, this is the median salary. So we have already got median. Then lower quartile, that means one fourth of the total quantities. That is, one fourth will be the fifth one. 1 2 3 4 fifth. So this one is the lower quartile, whereas 15th will be the upper quartile. So 5 10 15, this is 5, this is 10, now 11 12 13 14 15, this is the upper quartile. So how to calculate this? There are total 19 employees, and among this 19, 10th data lies at the middle. Okay, 10th data is lying on the middle. So median is this, and half of median, that means one fourth. One fourth is the fifth data, which is this we have encircled, and the upper quartile is the 15th data, or 15th the quantity is this, that is 335. Okay, let us write them down. We will write them down as first of all lower quartile. Okay, lower quartile L1. L1 is equal to, we have already decided it is this, how much, 312, and we will not forget to use these zeros. Look at these zeros are to be included. So how much is the lower quartile? Is $31,200. Then the median, there comes median. Median can be denoted as M. We have already got 320, $2 symbol, 320, and two zeros should be added everywhere, because key, in the key they have clarified that it is actually in hundreds. So 320 100. Then upper quartile, that means Q3, it was Q1. Okay, Q1, and this is Q3, that means upper quartile is going to be, what is upper quartile? We have already written, it is 332. So 33200. Okay, then they have told to write them the first median. So we will write median is equal to, let me change the ink. It is going to be median is equal to, median is, how much is the median? 31,200. 31,200. And then interquartile range is going to be, from upper quartile we will just subtract the lower quartile. So upper quartile is how much? Upper quartile is 33,200 minus, if we subtract, it is going to be minus, how much should be subtracted? Lower quartile. Lower quartile is 31,200. So if we subtract 312 from 332, it is going to be 332 or 330. Okay, sorry, we made a great mistake while picking up the data. It is going, let us count once again after erasing this. Let me erase this. So if it is erased, okay, then there are total 19 employees, and here 10th data. So let us find 1 2 3 4 5 6. So here 3, here, then 4 5 6 7 8 9, then 10. So this is our median. Okay, then this is 10th, 11 12 13 14 15. So this one is our upper quartile, and lower quartile is 5th data, 1 2 3 4 5. So this one is our lower quartile. So let us rewrite the quantities again. Our median is going to be, lower quartile is what, 312, so 31,200, and median is 320, and upper quartile is 335. Sorry, it's not 332, it is going to be 335. So it's just 5. Right? So from 335, if we subtract 3, not 332, it is going to be 335. It will be 335. Well, from 335, if we subtract 312, it is going to be 23. 2300 US dollar is the interquartile range. I think you have understood how to solve this. Means of what we do, the total number of data is divided into 3 parts. First lower quartile, then median, then upper quartile. Lower quartile means 1/4. If we divide the total quantity by 1/4, then we get lower quartile, and for upper quartile we just multiply by 3/4. Then median is just if we divide by 2. Here total 19 data, so 19 plus 1, it will be actually among 19, always 10 lies in the, look at this, here 1, here 1, here 10, here 19. So among this 19 is actually in the middle. If there are total 20 numbers, from 1 to 19 there are 20 numbers, so 10 lies in the middle. And then between these two there is another middle, the fifth data will be in the middle, and here 15th data will be the middle of the second half. This is 15. So fifth data, 10th data, and 15th data, these three have been used. Median is 10th data. 10th salary is 320, so we have written 3200 because 20, look at these zeros have been added to each quantity. Well, let's move on to the next question. The next question says, page number 7. Page number 7 says, the median salary of the Raven employees is 33 33,800 US dollar. The lower quartile is 32,000 US dollar, and the upper quartile is $34,400. Represent the data shown in the back-to-back statement leaf diagram by a pair of box and whisker plots in a single diagram. So for look at this, this is our box and whisker plots. For box and whisker plots, always there should be 5 information presented. So what are the 5 information? Let me show you. First, for petrol, let me write petrol on the left side. It is petrol. Okay, petrol. For petrol, first information is lowest wage or lowest salary. Then there will be lower quartile, salary of lower quartile. Then there will be median salary. Then upper quartile. Then maximum. Okay, maximum salary. So these 5 information are required, and everywhere we can write this dollar symbol. Dollar symbol is over here, 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 as well as here. So is for the Raven company. So Raven may be written with a different ink. So this is the different Ray one. Okay, for Raven. So first one is lowest value of salary. Then lower quartile 1. Then median salary. Then upper quartile. Then last of all, maximum salary of the data. So let us write one after the other. First, lowest. Okay, lowest of the page number 6. Here, lowest salary. How much is the lowest salary? Lowest salary is this. This one is the lowest. Look, this one is the lowest salary. So 300. And rest of them, and upper salary is how much? 368. So we can write lowest is 300, upper is 368. 300, lowest is 300. Sorry, let me change the ink. Lowest is 300, and 2 zeros should be added, and maximum salary is 368 dollar, and 202 zeros should be added. And first, our lower quartile we can copy from there. Lower quartile of this one was, how much was the lower quartile? Lower quartile was 312, and upper quartile was 335. Lower quartile 312, and median 320. 312 and 320. 312, 312 and 320. Sorry, 320 was the median, and 2 zeros added, and the upper quartile. How much was the upper quartile? Upper quartile was 33500. 33500. This is 33500. Well, so we have written the information of petrol. Then Raven. For Raven, lowest wage was, how much was the lowest wage? Lowest was 32. Let me erase this so that we can see them clearly. Okay. So lowest, yes, this is the lowest. Lowest is how much? 3200. Lowest is 302. This is lowest salary, and highest salary is 369. Lowest is 302, highest is 369. 302, 302, then two zeros. Then highest is 369 US dollar symbol. Dollar symbol should be everywhere. Everywhere there should be dollar symbol. Okay, highest is 369 US dollar. Then lower quartile, we will find the lower quartile of Raven company. Okay, lower quartile is the fifth data, fifth salary. So one, two, three, four, fifth. This is the lower quartile. Then what will be the upper median? This is a fifth. 6, 7, 8, 9, 10. So this one is our median. Then upper quartile will be 11, 12, 13, 14, 15. This one. This one is our upper quartile. Okay. This one. So what is the information we are going to write? First we will write lower quartile is 320. Then median is 338. Lower quartile is 320. 320. Let me write it. Lower quartile is 320. Then 100. Then median was, how much was the median? Yes, median was 320. Median is 320 and upper quartile is, no, lower quartile is 320, median is 338, upper quartile is 344. So 338 and 344. 338, 33800 and 34400. Now we are going to represent this information in the box and whisker plot. Okay, so for the first one, on top of the figure we will draw petrol, because petrol lies on the left side. So for petrol, lower quantity is how much? 30,000. So let it be, let's start from 30,000. This is 30,000. Okay, let's here 30. We can avoid 1000. It's 30. So after 10 it will be, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 10. Here we can write 40. This is 40. After that 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be 50. This is 50. This is going to be 50. After that there will be 60. So 1, 2, 3, 4, 5. I think it's better we take two squares as one unit. So it will be better for us to draw. So let it be 40 in that case. 20 every 20. This is going to be 40. Well, then I will have to erase this. This is 40. 40 is over here. 40. 40 is over here. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, 17, 18, 19, 20. So it is going to be 50. Okay, this is 50. 50 after 50, then 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is 60. Okay, our maximum data is how much? Maximum is 69. So if we get 18, then it's not possible in this case, in this way. um then what can we do? 40 will be over here. This is 50. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 40. So here it is 40. 40 is over here. Then it is going to be 50. Let me erase this one. This is 50. Let's write here 50. This is 50. Then it is going to be 70. Then it is 60 will be over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our 60 and it is going to be 69 maximum. Well, the rest of them may be erased. So let us erase this. It is no more 50. It is 69. Well, here we will write 69 and it is unnecessary in this case. 69. Well, it is 69. Okay, for the petrol, look at this. For petrol, our lowest salary was how much? 30,000. So let us write 30,000. Let me show you the whole of the figure. Okay, 30,000. So where is 30 lying? 30 is this one. We are starting with this 30. Um, it may not be exactly over here. Okay, 30. After that, let me erase some parts. It is unnecessary to write so long. Then the lower quartile is 312. That is 3100 and then 300, 1200. So if this is 30,000, so we skipped that two zeros. Let it be 312. So 312 is going to be 1, 2, just over here. Okay, just over here. Yes, over here. After that, the median is 320. So 320 means it is 40. So if it is 40, sorry, I will have to rewrite this because it is getting too smaller. So our maximum salary is 369. So it is less than 40. So it may be 31. It is, let it be 31. Over here it is, so it will be 31. Let it be right, 31. Suppose this is 31, then what will happen? It is going to be 32. This is 32. 32. Then 33 is going to be 33. 33. 33. It must be 34. Just the next one. It is going to be 34. 34 will fall over here. 34. Then that's all. So this is unnecessary. We will just erase this unnecessary line. This is unnecessary. Well, so our first lowest quantity is 30 and then the lower quartile is 31.2. So 31.2 is, let me erase this, then this is no more necessary. This is no more necessary. Okay. So 31.2. I mean 312. So 31.2 is just this one. Little bit zoomed out. So 31.2 is this one. Here is 31. So it is just this line. 31.2. So 31.2 is this. Okay. After that, then the median. How much is our median? Median is going to be 320. So 320 means 32, which is this line. Yes, this is the median line. After that, upper quartile is 335. Okay, 335 is over here. 33. Then if 34 is over, so 35 is going to be just over here. Okay, this is 35. After that, maximum is 368. That means 36. So if it is 35, so 36 and 37, 38 is going to be over here. Over here. Now this is our box and whisker graph for petrol. Okay, it will be just joined, not like this. It is not straight enough, but you can use your scale for drawing this. So this is our box and whisker plot for petrol. This is for petrol. This is for petrol. Similarly, we will draw the box and whisker plot for Raven. Okay, for Raven maximum is what? 369. So 34 at is, as this is 368, so 34 here, 35, 35 and 36. 35 is over here and 36 is going to be over here. 36, so 36 9 is going to be just over here. Let me erase this unnecessary mark. Okay, 36. Then for Raven, the lowest, how much is the lowest salary is 302, that is 30.2. It is going to be just 30.2. 30.2. So it was 30, so 30.2 maybe over here. This is 30.2. After that, there is the lower quartile is 320. 320 is same actually in both cases. So this is 320. 320. After that, 338 is the median. 338. Okay. 338 means it is less than 34. So it is just over here. Okay. Over here. After that, the upper quartile is 344 after 34. So after 34 but less than 35, it is over here. Then 369 is the upper, 369 is just over here. Then how will we draw this? We are going to join this line. We are going to make a box. This is the box and our, this is for what? Raven. Raven. It took huge time for me to draw this because it's a little bit difficult to draw on a device. So that is what the box and whisker plots for both of the salaries of companies. Now the question number C says that comment on whether the mean or the median would be a better representation of the data for the employees of petrol. For petrol, look at this. For petrol, it was what? Minimum was, for mean, where was mean? Look at this. The mean is, let me change the ink. Mean was for petrol, it is how much? Mean was 320. Whereas, I mean, median was 320. Whereas extreme value is what? 368. So, mean cannot, median would be the better, because as there is an extreme value, this extreme value will not show the more accurate mean of the. So for better representation, we will opt for median, because actually there is an extreme value. If we use mean, it will not be as accurate as the presentation of median. So we will write median will be, median is better representation, representation of the data, because there is an there is an extreme value of how much, what is the extreme value, because skipping extreme value of what, 368 US dollar. Okay, so this is actually, median is better because the extreme value of due to the extreme value of the salary. If I show you here, look at this, page number 6 here, look at this. In between them, it is all about petrol. Where is the median? Let me erase this. Where is the median? Median is over here. This one is the median, this one is median. Okay, this one median, it is lies at the central position. But if you find mean, there is a huge gap in between this data. That's why it will not be as accurate as the median. So let me show you the final answer. This is the final answer to question number C. Now, it has taken a lot of time for me to complete the box and whisker plot. Yet it may not be accurate, but I think you have got the point how to draw a box and whisker plots. Thank you all, and fi amanillah.